Good morning, everyone. First of all, I thank IAVM for providing this opportunity to share and spread the knowledge of Vedic math. The topic I have chosen for today's presentation is quadratic solutions, special and general methods. Abstract. Quadratic equations are polynomial equations with the greatest degree of 2. The general quadratic equation is ax square plus bx plus c equal to 0. Quadratic solution is value of the variable for which the quadratic equation is satisfied. Quadratic solutions may be rational, irrational or complex numbers. The quadratic equation has a maximum of 2 solutions. There are several methods available to find solution of quadratic equations. Using Vedic math methods, we can find solutions without memorizing the lengthy formula. This paper shows finding quadratic solutions using Vilokanam and duplex method. Objectives of the paper are smaller integer solutions using Vilokanam for a equal to 1, smaller integer solutions using Vilokanam for a is not equal to 1, and general method using duplex. Product of binomials. Binomials are expressions with two terms. Consider two binomials x plus m and x plus n. Find their products using vertically and crosswise. X times x is x square. M times x plus n times x is m plus n times x. And m times n is mn. It is in the form of general quadratic equation ax square plus bx plus c, where a equal to 1, b equal to m plus n and c equal to mn. Type 1. In this method, coefficient of x square, a is 1. Let us take an example, x square minus 10x plus 21 equal to 0. Here a equal to 1, b equal to negative 10 and c equal to 21. B represents m plus n and c represents m times n. We should find two numbers whose product is 21 and the sum is negative 10. Negative 3 times negative 7 is 21 and negative 3 plus negative 7 is negative 10. So m is negative 3 and n is negative 7. We can rewrite the equation as x minus 3 times x minus 7 equal to 0 and x equal to 3 and 7. Next example, 6x square minus 30x minus 36 equal to 0. Here the coefficient of x square is not 1, but 6 is a common factor. So take the common factor and factorize the remaining terms. We can rewrite the equation as 6 times x square minus 5x minus 6 equal to 0. Now a equal to 1, b equal to negative 5 and c equal to negative 6. Which means m plus n is negative 5 and mn is negative 6. We should find two numbers whose product is negative 6 and sum is negative 5. Using factorization, we find negative 6 and 1 whose product is negative 6 and sum is negative 5. M equal to negative 6 and n equal to 1. We can rewrite the equation as 6 times x minus 6 times x plus 1 equal to 0. X is 6 and negative 1. Type 2. Here the coefficient of x square is not 1 and there is no common factor. Let's take an example, 3x square plus 7x minus 6 equal to 0. Divide the entire equation by 3. So the equation becomes x square plus 7 over 3x minus 6 over 3 equal to 0. A is 1, b is 7 over 3 and c is negative 6 over 3. M plus n is 7 over 3 and m times n is negative 6 over 3. We should find two fractions whose product is negative 6 over 3 and the sum is 7 over 3. 9 over 3 times negative 2 over 3 is negative 6 over 3 and 9 over 3 minus 2 over 3 is 7 over 3. M is 9 over 3, which is 3, and N is negative 2 over 3. The equation becomes x plus 3 times x minus 2 over 3 equal to 0. X is negative 3 and 2 over 3. To avoid fraction, take product of outer terms 3 times negative 6 equal to negative 18 as mn and the middle term 7 as m plus n. So we should find two numbers whose product is negative 18 and sum is negative 7. By factorization, we find 9 and negative 2 whose product is negative 18 and the sum is negative 7. Here the coefficient of x square is not 1, so write the numbers with 3x. The factors are 3x plus 9 times 3x minus 2. After divide the entire factors by 3, we get x plus 3 times x minus 2 over 3. X equal to negative 3 and 2 over 3. Next is general method using duplex. Using this method, we can find rational, irrational or complex solutions. Let us take an example. 3x square plus 8x minus 2 equal to 0. If the first term is a perfect square, it would be easy for calculation. Here 3x square is not a perfect square. So we multiply the entire equation by 3. The equation becomes 9x square plus 24x minus 6 equal to 0. Now we find square root using duplex. Square root of first term 9x square is 3x and twice of 3x is 6x, which is a divisor. Divide the next term 24x by 6x gives 4. To find the remainder, subtract duplex of 4 from negative 6. Negative 6 minus duplex of 4 is negative 6 minus 16 is negative 22. Now we write the equation in completing square format. 3x plus 4 the whole square minus 22 equal to 0. On further simplification, we get x equal to negative 4 plus or minus square root of 22 over 3. This is another example for duplex method. The equation is 16x square plus 8 root 3x plus 651 equal to 0. Here the first term is a perfect square term. Using duplex, find the square root with remainder. Square root of 16x square is 4x and twice of 4x is 8x is the divisor. Divide the next term 8 root 3x by 8x gives root 3. To find the remainder, subtract duplex of root 3 from 651. 651 minus duplex of root 3 is 651 minus 3 is equal to 648. Now we can write the equation in completing square format. 4x plus root 3 the whole square plus 648 equal to 0. On further simplification, we get x equal to plus or minus square root of negative 648 minus root 3 over 4. Using this method, we can avoid lengthy calculations using formula. Conclusion. From ancient days till today, there are so many methods available to find the factors and solutions of quadratic equations. For small integer solutions, we can use VLOCANOM. For solutions including larger integers, decimals and complex numbers, we can use the duplex method. We can conclude that Vedic math sutras and tools are applicable not only to numbers but also in algebra to get the solution in a straightforward way. Here are the references. Before I conclude, I would like to thank my parents and my family who always support me. I owe my deepest gratitude to Sri Bharatikrishna Tritaji and my teacher, Professor Kenneth Williams, who lit the light of Vedic math in my life. My special thanks to IAVM for providing this wonderful opportunity. Once again, I thank you all. Thank you.